Hi everyone, my name is Robin Kanatzar. I am an iOS and Android engineer, and today I'm here to show you how you can get started making your iOS, Android, and Flutter applications more accessible. This morning you heard Nicola talk about accessibility in technology in general, and earlier this afternoon you heard Lauriane talk about accessibility on the web. Well, this talk, it's finally our turn. We will be talking 100% mobile. I will show you some of the most common accessibility issues that you may have on your application right now. I will show you how you can identify them with manual testing and with some tools provided by Apple and Google. Finally, we'll walk through maybe the simplest solutions to each one of these issues on iOS, Android, and Flutter. In the big picture, oh my goodness, okay, that cuts off the bottom. Is there any way, organizers, that we can have the bottom show up above the subtitles? Is anyone here? Thank you. Okay. Merci. Pas de pression. Allez. Ouais. Merci beaucoup. Okay, where was I? In the big picture of your accessibility journey, remember that this is a getting started talk. So we are taking our first step in the right direction to having an extremely accessible application. Right now, if you look at your application, you could have a situation like Nicola described this morning, where he tried to use an application with his screen reader. He was able to put all of these items in his shopping cart, but because the application wasn't accessible enough, he got stuck on the last step and couldn't actually complete his purchase. At this point, he's frustrated. He wants to use the application, but he can't complete the task, so he may uninstall the application and try the competitor's application. So, not a good place to be. After this talk, after our first baby step, you have fixed some of the most common, most frustrating accessibility issues in your app. At this point, a user like Nicola can complete the task he has set out to do. It may take him longer. He is certainly still frustrated at the user experience, but because he can complete what he wants to do, he doesn't immediately uninstall your application and try a different one. So we are on the right path here, but the goal of your accessibility journey is way up here in the corner, where we are no longer talking about user frustration. Instead, we are talking in terms of user enjoyment and delight at your app experience. At this point, not only have you made your app accessible, but you've made your app experience enjoyable for everyone, including those interacting via assistive technology. Now that we have that in perspective, I made a very small example app I'll refer to a few times in the presentation. This is an app I made for my colorblind boyfriend so he can pick out his clothes for work while his girlfriend is away speaking at a conference. So he can take a picture of a shirt, it'll tell him what color it is. He can take a picture of his shirt and his pants, and it'll tell him if it matches or if it shouldn't be worn together. Simple enough, but it has some accessibility issues, some of the same that you may have in your application. So I'll refer back to this one as we fix them together. Okay, two terms I want to go over before we get rolling with the issues. The first is the Web Content Accessibility Guidelines, or WCAG, as some people abbreviate it. This is the industry standard set of guidelines for how to make your web and mobile content accessible. So throughout the presentation, I will be referring back to some of their success criteria and quoting them, because on our accessibility journey, we do want to look at these industry standard guidelines. The second term that I've actually used already is assistive technology. Assistive technology is a very general term that describes things that can help you in your daily life. This could be something physical, such as a wheelchair ramp that helps people easily enter a building. Or in our case, this could be something digital, like the screen reader on your Android or iOS device. There are many types of assistive technology when it comes to your smartphone. For today, I'm only talking about the first one, which is a screen reader, but I wanted to clarify because I know I will interchange assistive technology and screen reader during this presentation. But just know that screen reader is only one kind, and you should, ideally, later on in your accessibility journey, be preparing your application for all types of assistive technologies, not just the screen reader. Our good friends at Apple and Google are big fans of accessibility. So much so that they've given us some tools to help us identify if we have accessibility issues in our application. This first one is for all of the iOS devs and Flutter devs running on iOS. As a show of hands, who develops on iOS? I'm curious. Got a few? Okay. How about who develops for Android? Okay, a bit more. And what about Flutter? Okay, we have a nice mix here. So this is good. So this tool for Flutter devs on iOS and for iOS developers is called Accessibility Inspector. You can launch this directly from Xcode, and it does a lot of things, but for today, I want to point out how it can run an audit on the current screen of your application, either running in the simulator or on a real device. So to use this to identify issues, you would have Xcode open, working on a new screen. You would launch Accessibility Inspector, click Audit, and it will show you a list of warnings if it detects any problems on that current screen. For Android devs, you have something very similar. This is called Accessibility Scanner. It's an app by Google you can download from the Google Play Store. Then on a device, you activate it from the accessibility settings of the phone. When it's active, it overlays a blue button on top of the screen. And when you click the blue button, it does an audit, just like for Accessibility Inspector on iOS, and it will give you warnings if it detects accessibility issues. The last tool is something interesting for you Flutter devs. Not only can you use Accessibility Inspector for iOS, Accessibility Scanner for Google, but you also have a semantics debugger that you can activate with one line of code and a hot reload. It does rhyme. Here, you can activate the property. Let's see, you can set the property Show Semantics Debugger in your application, so probably in your main.dart, that when you set that to true and do a hot reload, your UI will change from the typical UI to this view, which shows you what is exposed to assistive technologies. So the text, which is too small to read, don't worry about it, the text would be the exact text that a screen reader would read aloud to the user for that element. So during your development, it's only one hot reload away. This could help you debug if you're hearing something by the screen reader that isn't what you expect. Tools are wonderful, but in the accessibility world, we can never get rid of manual testing. And that is because tools will answer simple questions for you. They can answer, does something exist? Is this element bigger than the required size that we have input? But they can never answer a question like, does this make sense? And for that, we need the human component with manual testing. For manual testing, we will be using just a screen reader. A screen reader is exactly what it sounds like. It will read aloud a description of each of the elements on the screen to the user. It targets low vision and no vision users, and there are a few ways that you can navigate. The first way that you can navigate is often called Explore by Touch. This way, once you have the screen reader activated on your device, you can put your finger on the screen, drag it around, and as your finger passes over an element, it will tell you the description for that element. So that's a good way to explore the screen, literally, and see what is there. A second way that you can navigate using a screen reader is by swiping. When you swipe left and right, you can navigate from element to element, usually from the top to the bottom of the screen. I will show you like this. There we go. I'm not a designer, so that was my best animation. The final instruction I want to give you for some of the basic navigation with a screen reader is that once you have moved the focus over a control or a button, you can double tap anywhere on the screen and that will activate the button. So with those three things, with the Explore by Touch, swiping through the elements in order, and the double click to activate a button, those are the basics that you can get started manipulating your application with a screen reader. The names that you'll hear most often instead of screen reader are VoiceOver for iOS and TalkBack for Android. Although you have many options for the screen reader on Android, this is the default. So I will just refer to TalkBack. Okay, time to get to the good stuff. We're going to walk through 6 accessibility issues that you may have on your application. The first of which has to do with color contrast. So color contrast is the difference in brightness between the foreground and background colors. The higher the contrast, the easier a text is to read. And the lower the contrast, the more easily the letters blend in with the background, and it makes it hard, difficult for some users to read. This obviously poses big problems for someone with low vision, but it poses problems for all of your users if they're in a bright setting, they have their screen brightness turned all the way up, but they still can't read the text in your app. So our goal for fixing an issue with color contrast is to increase the contrast to a minimum recommended level. And this minimum recommended level is represented by a contrast ratio that everyone seems to agree upon. It is 4.5 to 1. When we look at the Web Content Accessibility Guidelines, they talk about this 4.5 to 1. They also give an exception for extremely large text, saying that it could have a lower contrast ratio of 3 to 1. But if you remember just one ratio from this talk, remember 4.5 to 1. Apple in their Human Interface Guidelines also refers to this ratio, recommending to use it for text sizes of 17 and below. And Google in their Android Developer Accessibility Guidelines, that's the name, they also recommend this for font sizes 18 and below. How do you know if you have an issue with color contrast? Here in the example app, you can suspect that the text just below the title is too light. It's a very light gray. But to know for sure, you have 2 separate ways. The first of which is you can go online and find one of many free color contrast checking tools. On a website like contrastchecker.com, you can input the hex code for the text and the hex code for the background. It'll calculate the ratio. And in our case, it says the ratio is 2.4 to 1, so we do have a problem with our color contrast. It is too low. A second way that you can detect a color contrast issue is with the tools provided by Apple and Google that we just saw. You can launch either Accessibility Inspector for iOS or Accessibility Scanner for Android. And during the audit on both of these, it will show you a warning if they detect a text and background having too low of color contrast. So the fix for this, there's no code really to show for both iOS, Android, and Flutter, is simply to find 2 colors that make a sufficient ratio and replace those in the color file of your application. And voila, we have fixed the first accessibility issue. The second issue I want to talk about is related to dynamic text sizing. You may not know that users can set a preferred font size in the system settings of their phone. For instance, my mom, she has customized her phone to have the largest possible font size. And this is really cool because the text in your application will react to that. It will get bigger if the user has set a larger font size in the system settings, or it should. And the bigger the text size, the easier it is to read for your users. So this helps out a lot of people with low vision, people who forgot their glasses. A lot of your user base enjoy this. But there's a few things that we can do as developers in our user interface that could make the app experience at a larger font size not so good. So our goal is to make sure that our layout, as the font size gets bigger, that it remains readable and it remains functional. The Web Content Accessibility Guidelines, they talk about this, saying specifically that text should be able to be resized 200% without losing content or functionality. Apple and Google don't mention the 200% specifically, but both of them recommend making sure your layout is still usable at large font sizes and testing regularly on all sizes of devices and sizes of fonts. The best way to know if you have a problem, it's pretty manual, but grab the smallest device that you support, crank it up to the largest text size that you can on your device, and see what's broken. Here in our example app, I did just that. It's not the smallest device I could have used, but we still have a pretty broken layout. To fix it, no matter the platform, there's a few things that we can do. You may have a broken layout because you have enforced line limits on text. This can cause things to get cut off with the larger font sizes. And this is okay if your text is not critical to the user, if it isn't so important. But here it's very important. This is the instructional text that's telling the user what to do on this screen. So I would like to go in and remove this line limit. Another common problem is if you have fixed height somewhere. If you have hard-coded the height of these buttons to be 30, as the text gets bigger, we have completely lost the text and most of the icons that were on the button before. And another thing that can help save your layout, if it is broken at larger font sizes, is to use adaptable views, such as a scroll view. Even if on a larger device at the default font size, you don't think you need a scroll view, when you're on the smallest device and the largest text, you need that scroll view. So things can expand, the user will have to scroll a bit more, but at least they will see all of the content and your app will still be functional. But because you guys are all developers, you know how to fix these issues. I'm not going to spend too much time on talking about fixed heights and line limits. We're going to talk about the important stuff on individual to each platform. Here we have a problem where this text did not resize based on the system settings. So for each platform, we'll show what you need to do. I'll show what you need to do to make sure that that resizes correctly. On iOS, instead of fixing a font size, it's better to choose a text style that Apple provides. Some of the text styles include title, body, footer, typical names there, and these are the default sizes that it will start with. But when you choose a text style instead of a specific font, Apple will handle rescaling your text as the user changes the preferred font for the system, preferred size for the system. So if you are on iOS and working in UIKit, you can do this by calling the preferred font for text style method and also setting a property adjust font for content size category. That is a mouthful, but you set that to true so your text field can resize based on the system settings. On SwiftUI, text in SwiftUI supports dynamic type by default. But if you want to specify a text style, you can do so with the font modifier like we did here. On Android, you can set a specific font size, but you want to make sure that you are using scale-independent pixels and never density-independent pixels. So I think you already get a warning in Android Studios for that, but yet another reason to use SP for your fonts. There is an example in XML and a quick example in Jetpack Compose. Finally, on Flutter, the text resizing is handled automatically as well, except if you override this property here. So we have this text scale factor that you can use to multiply the size of the text if you want to make it bigger or smaller, but the problem when you override it is it's static. It won't change when the user changes the text size in the system settings. So if you can avoid it, don't override that, and you'll be good. With all of these changes in place, this may take a few iterations to make sure your layout isn't still broken on a small device with a large font size. But after that, you have your app is functional and readable in this case, and you made your app a little bit more accessible. Moving on, we have a third accessibility issue that you may have, and this has to do with touch targets. A touch target is a physical area on the screen that would activate a control such as a button. In the case of a button, this is not only the button, but the padding around it. It's anywhere on the screen that would activate the control. When this touch target is too small, though, this poses problems for users with really big fingers, someone who just got a manicure, or someone with a medical condition where it is difficult to make precision touches on the screen. So our goal is simply to make sure all of the interactable elements on our app meet a minimum size. And this minimum size, if we ask the Web Content Accessibility Guidelines, they talk about 44 by 44 pixels, which approximates to 7 to 10 millimeters on the screen, depending on the device. Apple also has 44 by 44, and Android mentions 48 by 48, so they're all pretty consistent. If you're dealing with Flutter, you may want to shoot for 48 to cover both cases at the same time. But let's talk about how you know if you have this problem. An easy way to know if you have a problem on iOS or on Flutter for iOS is to use, again, this Accessibility Inspector tool. Run your app on the simulator, from the tool, launch an audit, and here in this case, if there is a problem with the touch target size, it will give you a nice warning saying the width is good enough, but the height is only 30, so you need to make that more than 44. Similarly, on Accessibility Scanner for Android, when you launch your app, run an audit, with Accessibility Scanner, it'll give you a warning for touch target if the button is too small. Easy enough. Now that we have identified it, fixing it, you have a lot of ways you can fix it depending on your layout on your phone, depending on how you've nested these touch targets. The simplest way is to think about minimum width and minimum height. So in iOS on UIKit, you can set a constraint in in the storyboard, yes. You can set a constraint in the storyboard to have a minimum height or minimum width. You can also set that programmatically. So this will allow your button to get bigger with the text size, but also make sure it never gets smaller than you need. Also, on SwiftUI, you can use the frame modifier, which provides a minimum width and a min height value there. On Android, you have in XML a min width and min height. So it does the same thing. And in Jetpack Compose, you could use a size in modifier with min width and min height. On Flutter, you can use simply a box constraint, talking about min width and min height as well. But just keep in mind, this is the simplest solution to your touch target problem. You can also play around with padding on your layout if you have extra space around your button. You could even get so fancy to use touch delegates, where you have removed the on-click action from your button and maybe given it to a parent view, which is bigger. So this is the simple way, but there are many more ways out there. Okay, problem number 4. When I talk about accessibility labels, this is the textual description that would be read aloud by a screen reader. Like when I talked about exploring the screen by touch, this is what we would hear as we pass over an element. This is really cool, but we can have a problem if we have a label read out to the user for an element and it's unclear, or we may have an element that doesn't even have a label, so it just says button with no name before it. It's confusing for the user. So the better the label, the easier it is to understand on the screen, and our goal is just to make sure that we have a label for all of our elements, and that the label is, at a minimum, clear and understandable for the user. In the Web Content Accessibility Guidelines, and in Apple's guidelines and Google's, they all agree that we need to provide some sort of text representation of each element on the screen. To know if we have a problem, I recommend using manual testing. So launch your screen reader from the settings of your device, on a real device, not a simulator. And you're going to scroll through all of the elements on the screen. And for each element, make sure that a label is read out, and ask yourself, is this a clear enough label for this element? If you had no vision, would it describe it? Let's see. Here we go. Also, you could use on Flutter the semantics debugger if you wanted to see just quickly the textual representation that would be read by the screen reader. If you don't see a text inside of an element, then that means you have no label. So we are going to see how you would add a label in the code. On iOS, this is easy enough. In UIKit, you have something called an accessibility label that you can pass a string. And in SwiftUI, you also have a modifier accessibility label. In Android, we have, instead of an accessibility label, we have a content description. And you can set that in XML as the first line, or in Kotlin, the second line, and in Jetpack Compose, again, a content description. For Flutter, you have a couple options here. Some of the more standard widgets, like these two down at the bottom of the screen, have fields that are transformed into the accessibility label, such as tooltip for the icon button and semantics label on an icon widget. But if you are using a widget that does not have one of these fields, you can wrap that widget inside of a semantics widget and then use the field label. So at this point, if you've gone through, you can recheck your application by manually testing, going over each element, making sure there is the label and the label makes sense. Then you have solved your initial problems with accessibility labels. The 5th accessibility issue you may have, we're almost to the end, there's only 6. You may have a problem with the ordering of elements on your screen. So, being able to scroll through your screen is really cool with a screen reader, and normally this should go from the top left of the screen to the bottom right. But sometimes you could have a problem where the focus kind of jumps around the screen. It goes a little left, little right, little up, little down. And in that case, we want to override the order that the screen reader filters through, scrolls through the elements on your screen, to make sure it stays in this natural reading order. The Web Content Accessibility Guidelines talk about this as the focus order that they recommend should preserve meaning and operability. And Apple and Google, they do a lot of work to guess the order of your elements for you, but every once in a while their guess isn't correct, and we need to go in and manually change that order. You know if you have a problem in manual testing, because as you are scrolling through all of the elements on your screen, swiping right and left with your screen reader, you will notice if the focus jumps somewhere you don't want it to go. For example, here, when I ran the screen reader on this application, it first read the title and then it jumped to the floating action button. And then after the floating action button, it went back up to the description text below the title, which is not what I want. In this case, I want that floating action button to be the last thing read on the screen after the user has added 2 photos, and we want to calculate if these photos match in color. To do that, on iOS in UIKit, you have access to an array called accessibility elements. For a view, you can input the subviews in the order that you want, and you just have to make sure that each element you put in this array is available to be read by assistive technology, and by that, you just need to set this, make sure this property is accessibility element is set to true. For Swift UI, things are already pretty good, better than UIKit, because you are using HStacks and VStacks all over the place, so the system can guess most of the time a good order for the elements on the screen. But when you want to override it, you have a modifier, accessibility sort priority, which is easy enough. Just something to note that in this case, sort priority number 2 gets called first before sort priority number 1, which seems a little unintuitive, but once you know that, it is easy. Moving on to Android. In XML, you have something called the accessibility traversal after and accessibility traversal before, where you can tell for an element what other element comes before and after in the focus order. Here you can set it in XML or in Kotlin. And again, you want to make sure that the element is available to be focused by a screen reader or an assistive technology, and you can do that by making sure focusable is true. Unfortunately, I love Jetpack Compose, but there is not a way to do this on Jetpack Compose yet. It has been requested, but for the moment, there is a common workaround, and that workaround would be to listen to ask the system, is TalkBack currently running? And if TalkBack is currently running, then we will slightly modify the actual layout of our UI so that the order falls like we want it to. Here, where I said I wanted this floating action button to be last, I can listen and ask the system if TalkBack is activated. Then I no longer want it to be a floating action button. I want it to be in the list, the scroll view for the screen, as the last element, and that will fix my problem. To ask the system, is TalkBack running? You get a reference to the accessibility service, and you check these 2 values here. The is enabled and is touch exploration enabled. The second one is very specific to TalkBack, and if both of those are true, then you can modify your layout. Okay, for Flutter, the return of the semantics widget. When you wrap your elements in say you want to change the order of these 2 elements, you wrap each one of them in a semantics widget, and you have another property called a sort key that takes a double. Here you can pass in appropriate sort keys to modify the order, just like we did with the sort priority on Swift UI. Cool. So after you've made those changes, the order will more naturally flow in the natural reading order from the top left to the bottom right, and this will make your application more accessible and more understandable for someone who is swiping through all of the elements on your screen. The last accessibility issue that you may have on your application has to do with the number of elements on your screen. Here in the example app, we don't have much going on. There's just a few things. But I think about the production app at BetClick. There's a lot of individual elements on this screen. And without telling assistive technology specifically, they're going to try and present each individual element to the user. So that could take a lot of time to scroll through element by element. Because of that, we want to be efficient about what we present with a screen reader. And if we have elements that don't provide a lot of value, or images, pictograms, something, if they're decoration, we want to tell assistive technology, hey, you can skip this, don't focus on it, don't waste the time of the user by adding to their cognitive load without any benefit. Thank you, Apple. They put this in a very good set of words. But basically, it wastes the user's time if you start describing the decorative elements that don't add value and don't add context. So our goal is to identify those types of elements and to ignore them. And when I say ignore, this is ignoring the element from assistive technology, not from the UI. Nothing will change on the visible user interface here. Let's see, the Web Content Accessibility Guidelines, our master guidelines, they talk about this here and agree with Apple and Google, all saying that we should hide these decorative elements. The way that you can find out if you have a problem is again with manual testing. You launch the screen reader on your app, start swiping left and right to scroll through the elements, and for each element, ask yourself, does this element add value? Does it add context? Does it help the user perform a task? And if you're answering no to those, then you can consider it a decorative element, and in the code here, we will have it ignored by assistive technology. On iOS, in UIKit, you can set is accessibility element to false, and in Swift UI, you have the modifier accessibility hidden. You set that to true. I love the fixes that are one lines of code. In Android, you can set the content description to null, and also the important for accessibility to no. And in Jetpack Compose, all you have to do is set the content description to null. Flutter, finally, I have another widget to tell you about. Instead of the semantics widget, there is an exclude semantics widget, which does exactly like it sounds. You take your widget you want to be excluded from assistive technology, you wrap it into an exclude semantics widget, and it is ignored like you want. So at this point, if you rerun your application with the screen reader, you've ignored the decorative, pretty but useless elements, and your user experience is much more efficient as they're navigating through all the elements on your screen. That was the 6 accessibility issues you may have, so I'd like to wrap up now. As a review, we took our example app and we fixed issues like improving the color contrast, allowing dynamic text sizing without breaking our layout, enlarging our touch targets, adding labels, ordering our elements on the screen, and ignoring the elements that don't add value to the user. We learned a bit about a screen reader and how to manually test with some basic gestures. And we also learned about tools such as Accessibility Inspector, Accessibility Scanner, and Semantics Debugger. So with all of this, we've taken a step in the right direction on our accessibility journey, but never forget that the goal of our accessibility journey is still way up here in the corner. So I encourage you to fix these quick and easy fixes we talked about today, but keep reading, keep learning about accessibility, and most importantly, keep talking to your users. It is vital that you talk to users of assistive technology to get their feedback so you can get to this goal one day. That is the end of the talk for me. Thank you so much for your time and attention. Thank you, organizers, for inviting me here. And for Q&A, you can find me just outside of this cell. I'd love to answer all of your questions in French or in English, as you like. So Oh, and don't forget to fill out the feedback that you can find on the DEVFEST application on your phone. I would really appreciate it. Thank you so much again, and enjoy the rest of your conference.